The sea and its mastery was one of the greatest contributors to human civilization. Learning to navigate its waters provided exploration, food and resources, trade, and migration. We've come a long way since people first ventured off their shores, but in many ways little has changed since they bravely pushed off for the first time in wooden vessels. Putting to sea still remains unpredictable, dangerous, time-consuming, and expensive.
We've been sailing for thousands of years, but we've also been hurting people for thousands of years. The ocean is really, really dangerous. It is one of the hardest environments to operate in.
The energy is the most powerful, huge waves and storms to deal with. In some ways, it's much more difficult engineering in the ocean than in deep space.
According to our research, about only 5% of the oceans are mapped. And there's so much that we need to know about the ocean from a whole range of reasons to do with weather and to do with climate. And right now, we don't know a lot about what's going on.
From the shorelines to the subtidal to the deep waters. We simply will not get across it all with manned vessels. They're too expensive, too limited in what they can do.
Ships are awfully expensive. Depending upon the ship, $25,000 to almost $40,000 a day.
But there's so much more to know, so much more to understand, and observation technologies really are needed to be out there in the midst of it. It's a vast frontier for discovery.
What will truly change the game out in the oceans is the ability to access those vast areas without needing people on board and all the support systems that are required to keep those people safe. For every application that we currently do with crewed vessels, there are many more that are only feasible to do unmanned. But in order for these unmanned surface vessels to be successful, a lot of difficult problems need to be solved, and for that, we need to nurture the next generation of innovators. When a difficult real-world challenge presents itself, how do you inspire people to dive right into the middle of it and tackle the whole thing? One way is to hold a competition and invite the best of the best from around the world. The Pacific Ocean is the world's biggest ocean, and the Maritime RobotX Challenge has brought together teams from 5 countries who most depend on it: Australia, Japan, Singapore, South Korea, and the United States. These countries will send 3 teams each to attempt challenges that mirror those in real-world applications.
The challenges in the competition are exactly the challenges we have in the real world. They are critical things that need to be solved in a reliable way.
Because there are not many commercial USVs at the moment working, we're going to learn a lot from what the students can do.
Depending on the ideas that come out and how they solve some of these problems, there's a real chance that some of these ideas will actually perhaps become industry standard at some point.
This is a very precious chance for them to get exposed to those kind of work, which cannot be easily done through some class work.
For the last few months, I've been traveling to all of these countries to see for myself what unmanned surface vessels are being used for now and will be in the future. And what I found has spanned the gamut of maritime applications. Things like search and rescue, shipping security, environmental monitoring, fisheries management, and marine science.
Using this type of technology is going to transform the way that we do science for all the future students.
The students will be learning something about a field that is just starting to open up.
Experience counts. I believe that through the process of challenging maritime RobotX competition, every participating student can have invaluable experience directly related to the core technology of USVs.
If the RobotX Challenge throws up new products that will enhance the capabilities of the USVs and solve some of the difficult problems, I think that's something to be proud of.
Could we see the next big technological breakthrough in unmanned surface vessels at RobotX? Could the students on these teams ultimately be responsible for overcoming some of the biggest hurdles in developing the future of seafaring vehicles?
If they brought us something we didn't predict yet, expect yet, it is the competition's fruit.
RobotX.org will have daily recaps, a live webcast of the finals, and a more comprehensive look at my travels figuring out the bigger picture of unmanned surface vessel applications.